All right. Hello, and hopefully this video finds you well. Today we're going to start our review, pre-calc review, obviously. Just a reminder, I'm going to be posting everything on Schoology here. We are in Unit 6 still. We're reviewing Chapter 9. I have put more polar paper here, so if you run into issues with that, obviously you can open that polar paper and print that off if you need it. Okay. You shouldn't need a ton of it, but I just wanted to put that there and make that available in case you do need it. So there's more polar paper available if you need it. I'm also going to be posting the ghost notes of these notes onto Schoology. So you will have the option to print a copy of this off and take notes yourself instead of having to draw the polar paper if you would like. As I said, I'm going to be reviewing sections 1, 2, and 3 today. So we're going to go over those. This may be a little bit longer than normal, but bear with me here, and also bear with my drawing skills as we are trying to use my mouse instead of having a pen like I normally do at school. So, so let's go ahead and get started. All right. So as we said, we are in week 1. This is the first lesson for the week of March 30th. Okay. So in this lesson, here's what we're going to be doing. We're going to be reviewing how to graph in polar. We're going to be doing the distance formula in polar. We're going to be graphing polar equations and talking about the 5 types of graphs that work in there. And then lastly, we're going to talk about how to convert polar to rectangular and then rectangular to polar. So just a quick review of polar. Polar is always written in this way. So you're going to have an R value and a theta value. So instead of X and Y, polar works in R and theta. Just a quick review, R stands for radius, just like what it normally does in math. So R is, again, radius. Okay. That is the radius. And theta here is an angle. Okay, it's an angle. That angle can be in either degrees or radians, depending on the problem. Also remember when it comes to the graph, as far as the radius tells you how many circles to go out, and you can change this to fit whatever you need as far as scale, whether it's 1 or 2 or 5 or 10. For our example today, I'm going to use a scale of 1. And then your angle measures you can match up corresponding to the angle that is given. We always just use the 30-degree circles as we've talked about. So let's talk about how to graph these, starting with point P here. So we're going to go to 60 degrees, which is this line right here. And we said each one of these circles equals 1. So we're going to go out to 3 and put that point P right there. Okay, so that is P. Then Q, you've got negative 1.5 and 7 pi over 6. So again, that's in radians, 7 pi over 6. So we have to convert that back to degrees. So we take 7 pi over 6 times 180 over pi. That gives us 210. So 7 pi over 6 is the same thing as 210 if we remember our conversion factor, which is 180 over pi. And then you have a radius of negative 1.5. Now we have to remember, what does a negative radius mean? So 210 is this entire line. If it's positive, you go 1.5 this direction, so our dot would be here. If it's negative, you follow that same line, but you go in the other direction. So 1.5. And that is our value Q. And then lastly, we have R. R is negative 2, negative 135. So negative 135, we have to add 360 to. And if we add 360 to that, we get, so 360 minus 135. 5. So that's 5, that's 10, 5, 2, 225. So 225 is not on the unit circle or on our circle here, but 225 is this. And again, excuse my poor drawing, but you get the point here. So 225 is this imaginary line in between here, 225. And then it also goes this direction. And here it's 45. Okay, degrees. So then we have a -2. So it's -2. So +2 would be right here at that point, but it's -2. So we have to go the other way. 1, 2, and put R right there. So that's a quick review of graphing using polar. If you have questions on that, again, pause the video, practice quick if you need to review. If you have questions, again, please email me or make note of it, and we can talk about it on Monday in office hours. Okay. The other thing is, okay, how do I graph R equals 3? So if I only give you an R value, you count out 1, 2, 3, and that is this entire circle. And again, my drawing is not perfect here. It's that circle. And then 3 pi over 4. 3 pi over 4, we convert that is 150. It's 150 degrees. So for 150 degrees, you just draw, oh, yikes. You just draw that straight line. So again, excuse my drawing, but this is 150 here, and then this circle. So an angle is always a line. It's always that line, and a radius is always a circle. That's the biggest thing you have to know there. Okay. All right, then distance formula. If you remember, if I want to find on a polar point, if I give you 2 points, P1, let's say P1's right there, and P2's down here, okay? I want to be able to find the straight line between P1 and P2, and assuming our pole point is there. So you're going to have a line there and a line there. So it's essentially giving you a third side of a triangle. Okay. And again, just plug into that formula. It's plug and chug. Remember, this is very similar to law of cosines. That's where this formula comes from. But instead of having side lengths, or instead of an x and y, we're now using r and theta. Okay. So there's that. And again, you'll need, if you need some review on that, there's some examples. All right. So that was section 1. For section 2, there are 5 types of curves that we're going to talk about. There's cardioid, limacone, lemniscate, rose, and spiral. Again, I don't mandate that you memorize these. I don't, to be honest, don't even care if you're able to name what a cardioid, lemniscate, etc. If as long as you know, okay, cardioid looks like a heart, lemniscate or limacone looks like a snail, ribbon is a lemniscate, rose, and spiral. And remember, when we're talking about a spiral, it's an Archimedean spiral, so it looks like this. Okay. Rose, you're talking about petals. The ribbon, it makes a little ribbon similar to that. The snail, it's got a circle within a circle, and then the cardioid is just looks like a heart. And I've got the formulas and examples here. So you got rose. Again, there's the formulas for rose. Lemniscate looks like a ribbon. R and A are squared, and there's always a 2 there. Limacone is addition with 2 different numbers, A and B, and usually it has this little circle here in the middle. You have cardioid, which is the same number, A, there, and again, looks like a heart. And then an Archimedean spiral is just that itself, and that is there's no addition, no subtraction, as well as no trig. And for that one, this is the only one where theta has to be in radians. The rest of them can be degrees or radians, but the spiral must be in radians. So make sure you make note of that for when you are doing this. Instead of going 30, 60, 90, you would have to go pi over 6 etc. Pi over 3, pi over 2. So just make sure you have that with you, and hopefully you took a unit circle home. All right, so just reviewing how to graph using this. So you have r equals 3 sine of 2 theta. So to do this, you have to go through and graph every single point from 0 to 360. So you start with 0, sine of 0. Okay, well, if you're not sure, again, pull up a unit circle. Okay, so we'll do that. We'll pull up a unit circle. And hopefully we can get that fairly quickly here. All right, good. So here's our unit circle, okay? And now we're going to say, okay, sine of 0. So 2 times 0 is 0. So sine of 0. Sine again is our y value. So we look at 0, our y value. Cosine is x, sine is y. So sine of 0 is 0. Take that times 0. And so I know that I start at the center, our pole, 0, 0. Okay. Now I plug in 30. 2 times 30 is 60 degrees. Sine of 60. Pull up my unit circle. Sine of 60. The y value is square root 3 over 2. Okay, so I got square root 3 over 2. So for this one, you have 3 square root 3 over 2. And again, you can find that as a decimal and graph that. 60 degrees, 2 times 60 is 120. So go back to our unit circle. Sine of 120 is again square root 3 over 2. So again, we're talking about the same value. Times 3 is 3 square root 3 over 2. 90 degrees. 2 times 90 is 180. So I look at 180. 180 sine is 0. So 0 times 3 is 0. Okay. So 3 times, so 1.5 times 1.5, it's almost 3. So we're going to say, okay, at 30, we're here. At 60, we are at that same value. So here. And then we're at 90, we're back at 0. So we're going like that. Okay, now we need to do 120. 120 times 2 is 240. So I go to 240. That's negative square root 3 over 2. So now we're talking negative 3 square root 3 over 2. So 120, 3 square root 3 over 2 would be here. But again, it's negative, so we go opposite. And it's almost 3, so we put that right there. Okay, 150. So take that times 2. That is 300. 300 on the unit circle. The y value is again negative square root 3 over 2. So this is again negative 3 square root 3 divided by 2. And then at 180, 180 times 2 is 360. So again, that's going to be 0. So that's there. 150 is negative again, so it's opposite down here, and then we connect because it's back at 0. So there's our second pedal. So obviously we're doing, this is going to end up being rows. So hopefully you were able to figure that out based off the equation that we have our rows here. 210, take that times 2. 210 times 2 is 420. Well, that's bigger than 360. So we have to subtract 360 from that. So it's the same as 60 degrees. Well, we already know 60 is 3 square root 3 over 2. Okay. 240 times 2 is 480. Again, bigger than 360. So you have to subtract 360 and you get 120. Well, we already know that, or I'm sorry. Yeah, that's 120. And we know that is negative 3 square root 3 over 2. 270 times 2 is 540. Minus 360 is 180. Well, at 180, we already know it is 0. And I'm sorry, I screwed that up. I am trusting the value when I shouldn't. All right, so let's try that again. for these. All right, so 210 times 2 is, again, like I said, 210 times 2 is 420. Subtract 360, that gives us 60 degrees. 60 degrees is square root 3 over 2. So we were okay there. So that is 3 square root 3 divided by 2. Okay, I think it's 240 where we screwed up. 240 times 2 is 480. 480 minus 360 is 120. We look at the unit circle again. 120 is square root 3 over 2. So there's our problem. Times 3 gives us 3 square root 3 over 2. Okay, so if I graph that, 210 is 3 square root 3 over 2. 240 is 3 square root 3 over 2. 270 is back at 0. And we have our third pedal. Obviously, to save time, if we go through this, 300 degrees, it's going to end up being the exact same as at 120. So it's negative square root 3 over 2, negative 3 square root 3 over 2, and 360 will be 0. So I go 1, 2, and back to the center. So 1, 2, 3. So there we go. So that is our rows, and that is a review of how to graph. Again, just plug into the unit circle. Okay, so if you have any questions on the graph, please let me know. Last thing, converting polar to rectangular. So to go from polar to rectangular, you use these two equations. X equals r cosine theta, because again, x is cosine on the unit circle. Y equals r sine theta. Really, really simple. Okay, follow the examples that we went through in class. So if I have the point 5 pi over 3, well, x again is r cosine theta. So r is 5, plug that in, because again, this is r comma theta. And we're converting to rectangular. So we're converting this to x comma y. Okay, so our x value is r cosine theta. That was the equation we had. So I plug r in here, plug theta in there. And then I again look at my unit circle, cosine of pi over 3, pull up my unit circle. Pi over 3, cosine is x now. Pi over 3 is 1/2. I look at that, there's 1/2. 5 times 1/2 is 5 over 2, or again, as we talked about, that's 2.5. Okay. The other one, for y, you use r sine theta, same process. 5 times sine of pi over 3, plug in pi over 3, 2 sine, go to our unit circle, I get square root 3 over 2. And I get 5 square root 3 over 2, which is 4.33. Because again, we're rounding to the nearest hundredth. Okay. Here's a second example here if you need it. Negative 70. You can just enter that in on a calculator and find those values, making sure your calculator is in degrees. Okay. All right. The other way, rectangular to polar. This one's a little bit trickier. Radius, really easy. Square root of x squared plus y squared. Okay. That's just normal stuff. Theta, on the other hand, is a little bit trickier because it all depends on whether x is positive or x is negative. And again, if x is positive, you just do arctan, which again, arctan is just tan -1 of y over x. Okay. And then if x is negative, you have to add pi. And again, we talked about that in class as to why that works. So again, r, so I have xy. I'm trying to go from xy to r theta. So I'm going to have a radius and a theta. So plug the values in, find my radius, 14.42. And now I look and see, okay, to do theta, again, I have to check my x value. Well, x is negative. So that tells me I have to add pi at the end, as it says here. I plug in tan -1 of -12 over -8. Simplifies 3 over 2. You don't have to do this step. You can just plug that into a calculator and you get 4.12. Again, making sure your calculator is in degrees at this point in time. Okay. So hopefully there's no questions with that. If you have questions, please let me know. All right, last one, just a little bit trickier one. If I want to go from a circle, because that's what this is, a circle at the center of 3, 0. If I want to go from that to putting that into polar, again, using the equation we have there. Okay. And as we worked out in class, you have to FOIL this. Okay. So it's r cosine theta minus 3 times r cosine theta minus 3. That gives you that whole thing. Then you square r sine theta, which gives you r squared sine theta squared. And then you end up with this because the 9s will cancel each other out. Okay. Then we want to find what they have in common, which in this case is just, so we moved everything that doesn't have an r squared in it. Okay. We isolate squared terms, factor out the r squared, and then we use our trig identities, which tell us that cosine squared plus sine squared equals 1. And then we get rid of the r on both sides, and we get r equals 6 cosine theta. Okay. So what I want you to do to help review for this is do problems 1 through 8. Number 8 is going to be a little bit trickier, but go ahead and give that a try. Remember what cosecant means, and see what you can do with it. If you have questions, again, please let me know. I'm going to post this a little early, so if you want to get started on this early, you can. Again, let me know if you have questions. I will also post our lesson for Monday as well. All right. Hope you are having a great day, and we'll talk to you later.